Lesson 13.4 is about the sine function. In this lesson, we will learn how to find the domain and range of a sine function, how to find the amplitude and period to the sine function, and then finally how to graph the sine function. So these are the properties of the sine function. Your equation would look like y equals a times b, a times sine of b theta, where theta is the angle measurement and b is something multiplied times theta. And then theta is in radians, so you would see something like 3 pi fourths. A is the amplitude. The front number here is the amplitude, and actually it's the absolute value of A that is the amplitude, because the amplitude could be a positive or negative value. If A is negative, then your sine function begins by going downward, and if A is positive, it begins by going upward, similar to the A values on, say, a quadratic function. It tells you if it opens up or down. The B value tells you the number of cycles in the interval from 0 to 2 pi, and then 2 pi over B is how you calculate the period to the function. So let's give it a try. Suppose we have this information. What is the graph of one cycle of a sine curve with an amplitude of 2 and a period of 4 pi, where the amplitude is greater than 0? So if we were to graph this, start with the coordinate plane. The sine function always, well, it doesn't always, but the general form of the sine function begins at the origin. And then if A is greater than 0, it will begin by going upward to the amplitude. So if our amplitude is 2, it's going to curve upward till it reaches this value of 2. Once it reaches that value, it's going to come back down till it gets to the x-axis again. And this is 1/2 of a cycle. So then it's going to continue from here. It will go downward till it gets to the amplitude in the negative area and continue back upward till it gets to the x-axis again. This is what it will look like. This is one cycle of a sine curve, and the period is the distance from where it begins to where it ends. So since the period is 4 pi, we know that this x-axis value is 4 pi. So at the halfway point, we would be at 2 pi, and halfway between the x-axis values at the amplitude here would be 1 pi, and then at the minimum value here, this would be 3 pi, halfway between 2 pi and 4 pi. So that's what one cycle of the sine curve would look like. The equation then would be y equals 2, because that's the amplitude, and it's a positive 2 because they tell us that A is greater than 0. And then we would have sine of, so we're going to have b theta here. Okay, we know that the period to the function is calculated by doing 2 pi over b, and we know that the period to the function is 4 pi. So we have 4 pi equals 2 pi over b. So we're solving for b. Multiplying both sides by b gives us 4 pi b equals 2 pi. Dividing by 4 pi gives us b equals 2 pi over 4 pi. We know the pi's will cancel, and 2/4 is equal to 1/2. So then our equation will be sine equals 1/2 theta. Okay, if we go back to previous page, it tells us here b is the number of cycles in the interval from 0 to 2 pi. So looking at the graph, in this interval from 0 to 2 pi, we have a half a cycle, just up and down. A complete cycle is when you go up, down, and then back up.